Hi, my name is bchattar and this is my submission for the CS221 poster. I work in the area of catastrophe modeling and my project is about the earthquake loss models. Now vendors produce models which take the earthquake parameters and the distribution of exposures, and what they do is they create the property loss for California or any other region. Our region is mostly California, so our model is that. Now, what do we want to do? Now, this is a black box. So what we want to do is, can we replace the model, that black box, with an AI model to do the following things? Given the parameters, can we use it to estimate losses? And can we indicate it if the loss is above a certain threshold, which can be used for building options? The data is from AIR Worldwide Corporation, and they gave us 98,000 equally probable in simulated losses, which is a training set, and 61 estimated historical event losses. In addition to that, we decide to add two more variables to help us in this estimation, and based on our experience from the project progress. First thing is, for each epicenter, we looked at from census data the number of housing units within 150 kilometer. And thanks to Sudarshan, my advisor, pointed out, and we see that that value is similar to what the loss by each epicenter is. So it seems like a good variable. The second variable that we look at is based on the expertise or the knowledge in this, that North and South California have different levels of hazard, and large magnitude earthquakes, usually moment magnitude 7 and above, usually affect losses in slightly different then. So we have four zones. Zone 1 is in South California, these gray dots, and magnitude less than 7. Zone 2 is also in Southern California, but magnitude is greater than or equal to 7, is black points. Zone 3 is in Northern California, low magnitude is yellow points, and Zone 4 is Northern California, but magnitude, large magnitude, is red lines. Now what you notice is these black lines and red lines kind of line up nicely with the USGS map, which kind of gives you the hazard. So it seems like this will be a useful variable to use. The first thing that we do is we say, can we estimate the losses given the parameters and given these 2 9 variables by each earthquake? So we use three kind of models, the linear models, which is just simply without any interaction. We did play around with interaction, but that did not help much. Then k nearest neighbor. So we scaled the variables, and thanks to my advisor, this was an important step, and use grid search to get k. Um, Neural nets, we scale the variables and use 3 layers with 9 neurons each. Now, neural nets, mine is with the lack of my knowledge, enough knowledge, maybe this is a very simple model, and there can be better models out there. Now, the training sample, and this is the sampling error, and as you can see, this looks very bad. Okay, so this is less than minus 100%, this is above 100% error. So kind of those dominate. What do we learn? Training and test estimation error distribution, this is a failure. This is like total kind of disaster, a catastrophe, you can say. Surprisingly, the test sample results are marginally better. And given the complexity of the models, this is not a surprise. We have to introduce more variables like soil index and everything, capture attenuation functions to get closer. Next, we look at problem classification. Specifically, given the parameters, can we say which earthquake will have a loss bigger than or equal to $10 billion? We use two models for this, the k nearest neighbor classifier and the neural nets classifier. Here, it's not a complete catastrophe. These are the confusion matrix of KNN and the test. And as you can see, even though the red regions are not great because there's cross classification, but still, there's hope because in the green areas, there's quite a few probability, So it was not like minus 100% plus 100% case, but this is a much better scenario. So classification works in that scenario. So classification models are more successful than loss estimation models that we have tested. So what we'll do next is we try the loss estimation for a much smaller set of counties. And the second is Given the slight success in classification, we want to use reinforced type learning to kind of use the training data to come up with strategy from parameter characteristics to kind of and bet on whether the loss would be above 10 billion or less than 10 billion, and then test the effectiveness of that strategy with the test data. We'll also kind of describe a simple option in this arena and try to maximize the expected payoff using this reinforcement type learning. Thank you, and please let me know if there are any comments or questions.